Okay, so today we're going to learn about some special right triangles. So certain right triangles have properties that allow you to use shortcuts to determine side lengths without having to use the Pythagorean theorem like we did last class. So I know we all loved the Pythagorean theorem. However, we don't always have to use it on our right triangles if they follow some of these guidelines. So acute angles of right isosceles triangles are both 45-degree angles. And another name for an isosceles right triangle is a 45-90 triangle. So that just means that we have a 45-degree angle, a 45-degree angle, and a 90-degree angle. That's all it means. So if each leg has a length of x, then the hypotenuse has a length of y. You can solve for y in terms of x. So what I mean to say is that if we have a 45-45-90 triangle, both of our legs are congruent. Okay, and the length of the hypotenuse, which is just that side that is opposite of that 90-degree angle. So the length of the hypotenuse is the square root of 2 times the length of a leg. Okay, so if our leg is going to be S, so we've got S right here and S right here, then our hypotenuse is just going to be S times the square root of 2. Okay, so if we come down here, right here we see that our right angle is right here, which means that this is a leg and this is a leg. So this 9 equals S based on our theorem up here. Okay, so what that means is that our H is going to equal S square roots of 2. If we know that our S equals 9, that means that our hypotenuse is just going to equal 9 square roots of 2 because we're just going to plug in our S into this equation. And that's all we had to do. Okay, so if we come down here, we still know that since this is our right angle, that means that these two sides are our legs. So if we know that x is going to be that s square roots of 2, and we know that this 2 square roots of 2 is going to be our s, so our s equals 2 square roots of 2. What we're going to do is we're going to multiply, we're going to plug in our s into this equation. So we've got 2 square roots of 2 times a square root of 2. So when we do 2 square roots of 2 times the square root of 2, that's going to give us x equals 2 square roots of 4, which just equals 2 times 2, which is just 4. Okay, not too bad. So for this one, I'm going to draw it. So I'm going to have a right triangle that looks something like this, and these are both 45-degree angles right here. And it says the length of the triangle, or the leg length of the triangle, is 5 square roots of 3, and we want to know the hypotenuse. Okay, so that means that our S equals 5 square roots of 3, and our X is going to equal S square roots of 2, based on our theorem up top. So what we're going to do is we're going to plug in our S into this equation. So we've got X equals 5 square roots of 3 times the square root of 2, which just leaves us with x equals 5 square roots of 6. And that should be it. Okay, so now what if we want to define the length of a leg? So right now we know that the length of a hypotenuse is 6, and we want to find the length of our leg. So we know that our hypotenuse equals s square roots of 2, right? And we just want to find s by itself. So if we have x equals s square roots of 2, what we're going to do is we're going to solve for this s. So what we need to do is we need to divide both sides by 2, or by the square root of 2. That leaves us with s equals 6 square roots of 2, we have to rationalize this denominator over here. So what we're going to do is we are going to multiply both the top and bottom by the square root of 2, which leaves us with 6 square roots of 2 over 2. We can divide 6 by 2, which leaves us with 3 square roots of 2, which is what we want. And that's going to be our x. So right here, we're just solving for s. That's all we're doing, okay? It's the same thing over here. We've got our right triangle. Remember, I'm not an artist. So we've got our 45 degree angles. And it tells us that our hypotenuse, our longer side, is going to be 10. We know that 10 equals s square roots of 2. So what we're going to do is we're going to divide both sides by that square root of 2. Which leaves us with s equals 10 over the square root of 2. We need to rationalize that denominator because we cannot have a radical in the denominator. So that leaves us with 10 square roots of 2 over 2. And to simplify that a little bit further, we can do 10 divided by 2, which is going to be 5. So we've got 5 square roots of 2 as our length, or our leg length. I'm going to make that look like a 10. Okay. So if we move on to the next page, so we've got a high school softball diamond that's a square. So we know that every corner of our square is going to be 90 degrees. So if we cut it in half, that means we've got a 45, 45, 90 triangle. So it says that one of our legs is 60 feet, and we want to know the distance from home plate to second base. So we know that our distance is going to be our s square roots of 2, and we know that our s is going to equal 60. So our distance is just going to be us plugging in s to this equation, which means we've got 60 square roots of 2. And when we put that into our calculator, that's going to give us about 85 feet from home base to home plate to second base. Okay. So it's the same thing over here. If we've got a 100 by 100 foot garden, which means it's a square. Okay. And we have our diagonal. We want a path along the diagonal. So we know that this is 100 and this is 100. Okay. So our x is just going to equal that s square roots of 2. So if our s equals 100, means x equals 100 square roots of 2, which when we put that into our calculator should give us about 141 feet. The other type of special triangle we have is called a 30, 60, 90 triangle. So our 30, 60, 90 triangle has that our hypotenuse is going to equal 2s. Our shorter leg, so our short leg is just going to equal s, and our long leg, our longer leg, is going to equal s square roots of 3. So on these triangles, you will be able to tell which one is your shorter leg and which one is your longer leg. And from there, we'll be able to find all of our legs pretty easily. So if we go on to the first page, we're going to use our 30, 60, 90 theorem. Okay. So what we know right now is we know our longer leg, and our longer leg equals that s square root of 3. Okay. So if we have that 5 equals that s square root of 3, we want to find what that s equals. So we are going to divide both sides by the square root of 3. We get that, we get s equals 5 over the square root of 3, and we have to simplify that. So we are going to multiply both the top and bottom by the square root of 3. That's going to give us 5 square roots of 3 over 3. Okay. that is going to equal our shorter leg, which is D. Okay? Because our shorter leg just equals S. Okay? From here, if we know that this is going to equal that 5 square root of 3 over 3, now what we want to do is we want to find this this F, which is just going to be 2 times that S. So if we do F equals 2 times that 5 square root of 3 over 3, we're just going to multiply the top by 2, which leaves us with F equals 10 square roots of 3 over 3. And that's going to be it. Okay? So I believe this is our last page. Okay, so we have an artisan that makes a18 in the shape of equilateral triangles. So the height of each pendant is going to be 18 millimeters. So our height is going to be right here, and that's going to be our longer side of our triangle. So what we want to find is our hypotenuse. So we know our longer side, so our long leg equals S square roots of 3. And we want to find our S right here. Well, I'm going to change this. This isn't going to be S. This is going to be X. Okay. So we know that equals 18. We're going to divide both sides by the square root of 3, which leaves us with X equals X equals 18 divided by the square root of 3. We're going to multiply both the top and bottom by 3, or by the square root of 3, which leaves us with 18 square root of 3 over 3. And 18 divided by 3 is just 6. So we have 6 square roots of 3. Okay? From here, we know that our hypotenuse should be, so our S is going to equal 2 times that X. If our X equals the square root of, or 6 square roots of 3, that means we're going to do 2 times 6 square root of 3. Do 2 times 6, which is 12, and we're left with the square root of 3. We do the square root of 3, 12 times the square root of 3. That's going to give us about 20.8 millimeters. Okay, and our last problem, if we have that 18 millimeters is on the outside, we want to know what our height is. So if this is 18, our 18 is going to equal that 2S. Okay, so to find S, we're going to divide both sides by 2, which leaves us with S equals 9. And we know that our height is going to be S square roots of 3. So our height is going to be 9 square roots of 3. And when we do that in our calculator, it's going to give us about 15.6 millimeters. Okay. So for this section, we just have to remember to use our theorem. So we have our 30-60-90 theorem, and we have our 45-45-90 theorem. And those are the only theorems we need for this section.